So question 11 says, it can be considered procedurally fair that people who work hard earn higher incomes than those who do not work hard. So what do we mean by procedural fairness? So procedural fairness has to do with the rules or the process that led to the outcome. So when we're talking about fairness, when we're judging an outcome as fair or unfair, we're looking at the amounts that people are receiving in the outcome. So let's say you have two individuals who one is earning 50 Rand per hour and the other one earns 100 Rand per hour. In other words, the outcome of this is that one person gets more than the other. But then we get told that the reason why this person earns more than this person is because they worked harder than that person. Would we then judge that as procedurally fair? So it is procedurally fair because procedure-wise, through the process of judging somebody as having worked harder than another person, it does make sense that they should earn more. So this answer is true. Okay. Now, what if we think about the ultimatum game we just looked at, where one person gets 300 Rands and the other person gets 700 Rands? And let's say that I decided that the person, the proposer, so the proposer was the one who got 700 Rands, and the responder is the person who got 300 Rand. What if I told you that I selected the proposer because they were a brunette? Is that procedurally fair? Okay, so that would be discrimination. That would not be procedurally fair. So it's fine that people get different amounts based on their abilities or based on the efforts or the contribution they've made. But if I'm using some really arbitrary mechanism to decide who gets more, that isn't procedurally fair. Chani is a landowner and Paul is a spice farmer who pays a share of his output to her for the use of her land. New technology that increases Paul's productivity would increase the area of the economically feasible set. Okay, so I'm just going to draw a really rough picture. So in Unit 5, we said that there is some output that is being produced by a worker. So in this case, Paul, the spice farmer. And this output is being produced through the use of Paul's effort, his time. And so on the x-axis, we have free time. And when we plot output against free time, we end up with this feasible frontier. And we say that this is the feasible frontier for Chani and Paul combined. And the reason why it's combined is because even though Paul is the one who's producing this output, Chani is able to claim some of the outputs as the landowner because they have private property over the land. And so Paul has to pay a share to her for the use of her land. So this is the feasible frontier. We then say that because Chani has a choice whether or not she wants to work for Paul, in this type of model, there is no coercion. Chani can't force Paul to work. So Paul is able to choose whether or not he actually wants to farm. And the thing that allows him to make that choice is the fact that he has this outside option of some kind of unemployment benefits or ration from the state. So this is a ration amount. This is the amount of output that he would get if he didn't work. And then this point falls on an indifference curve, and we call this indifference curve the reservation indifference curve. In other words, every single point that lies on this curve gives Paul the same utility as at point Z. It makes him as satisfied as not working. The area between the reservation indifference curve and the feasible frontier gives me the economically feasible set. So these are all the outcomes that are feasible for Chani and Paul as a negotiation. So they're able to come to some contractual agreement that falls within this economically feasible set. Okay, now let's say that there is new technology, and this technology increases Paul's productivity. How would new technology affect this picture? So what in this picture would change? The feasible frontier would change. And the reason why is because if this is our production function, our feasible function is the mirror of our production function. So for the production function, we have the output against hours of work. The feasible frontier is production against free time. And so if Paul becomes more productive, the production function shifts up. And that would mean that the feasible frontier shifts up. And so if the feasible frontier in this picture had to shift up, that would make the economically feasible set larger. So the answer to this question is true. Greater productivity would increase the area of the economically feasible set. Okay, so substantive fairness has to do with the actual allocation. So when we're judging substantive fairness, we will look at the amounts that each person gets. So if we look at this outcome, one person gets 300 and the other person gets 700, we would say that this is substantively unfair because one person is getting less than the other. So that would be substantively unfair. Question 13 asks, an allocation will be substantively fair for all participants in a strategic interaction if it is Pareto efficient. So let's look at one of our games previously. So here we had an outcome yes, yes, and an outcome no, no. And we said that these were both Pareto efficient. Are we able to argue that no, no is substantively fair? And are we able to argue that yes, yes is substantively fair because they are Pareto efficient? Yes, okay, so no, we can't. We can't say that just because it's Pareto efficient that automatically the distribution of the resources is fair. So Pareto efficiency does not guarantee substantive fairness. So the answer to this is false. So this question 15 says Bruno is a landowner and Angela is a farmer who pays a share of her grain output to Bruno for the use of his land. Currently, if Angela does not work, she receives a ration of 2.5 bushels from the government. Okay, so this point here, outside the feasible frontier, represents the reservation option. So if these two individuals, Bruno and Angela, cannot come to an agreement, if they cannot voluntarily exchange, then this is where they'll end up. So at Z, Bruno gets nothing. And Angela gets ration. Okay, so that's the reservation option. Every allocation in this social interaction has to be compared to the reservation option. And then we will determine whether or not there's been a Pareto improvement or not. Of the 4 allocations, A, B, C, and D, which allocation represents a Pareto improvement over Z? So let's look first at allocation A. How would we define an allocation like A? What type of allocation is A? What name would we give to it? Yes, A is biologically infeasible. Okay, so taking that into consideration, would A ever be an outcome in this voluntary exchange? Would A ever even be on the table? No. Okay, so A is biologically infeasible. It would never be considered. Okay. So we can immediately eliminate A as a Pareto improvement over Z. Then let's look at allocation B. How would we refer to allocation B? Okay, so B is also never going to be considered because we know outright that Angela is going to reject it. Then for C, so let's consider C now. Is C a feasible option, right? C is on the reservation indifference curve. In other words, it would make Angela no worse or better off than being at Z. So C would give Angela exactly the same utility as she would get at Z. What would Bruno get at C? Bruno gets nothing. Okay, so if Angela gets the same utility at C as she does at Z, and if Bruno gets nothing, which is what he gets at Z, how would we talk about C compared to Z? Does C represent a Pareto improvement over Z? Okay, so let's think about what a Pareto improvement is. So a Pareto improvement means someone benefits, but no one loses. And so comparing Z to C, is anyone better off? No. Is anyone worse off? No. If we look at D, let's look at D. Is Angela better off at D than she is at Z? Yes, Angela is better off at D than at Z. Is Bruno better off at D than at Z? No. Okay, so if we compare D to Z, we can see that D makes Angela better off because D lies above her reservation indifference curve. So D gives Angela more utility than does Z. But Bruno is no worse off at D than at Z. So D gives him 0. And so comparing D to Z, this is a Pareto improvement because it's making Angela better off, but it isn't costing Bruno. And so D is the correct answer. D represents a Pareto improvement over Z. Is it clear why? Please repeat why D, okay? So remember, Pareto improvement means someone benefits, so someone is able to be better off, but no one has to lose in order for that person to be better off. So if we look at D compared to Z, at D, Angela is better off than at Z. And the reason why is because D lies above her reservation indifference curve. And remember, points that lie above an indifference curve gives more utility. Okay, so D makes Angela better off. At D, Bruno is no worse off than at Z. At D, Bruno gets nothing. At Z, Bruno gets nothing. And so what that means is that D makes Angela better off, but it doesn't make Bruno worse off. And so D is a Pareto improvement over Z. Please explain what you mean when you say it's not costing Bruno. So it's not costing Bruno because if we end up on the combined feasible frontier, it means Angela gets all of the output, so Bruno gets nothing. So D gives Bruno nothing, Z gives Bruno nothing. In other words, those two outcomes put him in the same position. If there was a point between the RIC and the FF, would Bruno choose that option as he is then get some bushels? Okay, so let's consider a point like that. Let's think about a point like this. Let's say this is E. Is E a Pareto improvement over Z? So is E a Pareto improvement over Z? Yes, it is. Okay, it's a Pareto improvement over Z because E lies above the reservation and difference curve. And so Angela is better off at E than she is at Z. And Bruno is better off at E than at Z because in this outcome E, Angela gets this amount and Bruno gets this amount because the total production is going to be on the feasible frontier. So E is a Pareto improvement over Z. And when we look at E compared to Z, both of them are better off at E than they were at Z. So what we can conclude from that is that any point that is inside the economically feasible frontier is a Pareto improvement over Z. In other words, if these two individuals can come to an agreement, if they can come to a contract, it's going to be better for society. It's going to be better for both of them. There's a Pareto improvement possible. The Karabo is a farmer who pays a share of her grain output to Dipuyo for the use of his land. This is a voluntary exchange. So there's a take it or leave it offer. The figure below shows their combined feasible frontier, as well as Karabo's biological survival constraints and Karabo's reservation in difference curve. Question A then asks, explain why Karabo's biological survival constraint curve gets steeper when she works more. So just to outline the biological survival constraint, so it's this function over there, it's that curve. And what we can see is that this is free time on the x-axis. So as we move in this direction, which means we're lowering free time, we're increasing work, this curve becomes steeper and steeper and steeper and steeper. Now let's remind ourselves what the BSC represents. So the BSC represents combinations of free time and grain that meet Karabo's basic subsistence or survival needs. Okay, so if we're at this point here at C, what we're saying is that in order to survive, and this should technically line up with 24, in order for Karabo to live a sedentary life, so by sedentary, I mean not working, you still have to eat something, okay? Even if you're not walking, talking, just breathing and thinking burns calories. And so to live a life in which you spend all your time doing nothing, you need some basic amount of nutrition to survive. We then move up along this biological survival constraint. So what we're saying is that as Karabo starts to work, she requires grain to sustain this work. But the more she works, the more grain she needs for each additional hour of work performed, because extra work brings extra exertion and therefore a higher calorie requirement. Okay, so the reason why Karaba's biological survival constraint curve gets steeper when she works more is because additional hours of work expend greater energy, which means her nutrition or calorific requirements increase at an increasing rate. Okay, so the slope of the BSC represents how much additional grain is required to make up for the time that is lost for free time and keeping her in subsistence, in a subsistence state, so in basic survival. So the slope of the BSC is a marginal rate of substitution, but it's not a marginal rate of substitution in the same sense as the reservation and difference curve, because what it's measuring is how much grain is willing to be sacrificed to have more free time and keep Karabo alive, so to keep her surviving. So along this line, it's not representing equal utility. In fact, if you move up along this BSC, you're actually becoming less happy. So you're less happy up here than you are down here, because essentially up here, you're working a lot, but having to consume a lot of grain to remain alive. Down here, you're working less and consuming less grain in order to stay alive. But that's going to make you less unhappy than if you are eating enough to work a lot just to survive. The next part of the question then asks, if Karabo works for 10 hours, would this maximize the economic surplus that can be shared between them? Briefly explain your answer. So if Karabo is working for 10 hours, it means that her free time is 14 hours. So we are currently looking at this line over here. So having 14 hours of free time and 10 hours of work. Looking at the picture, does this maximize the economic surplus that can be shared between them? Yes or no? Does it maximize the economic surplus? The slope at A and the slope at E are different. This tangent line at E represents the MRT at 10 hours of work or 14 hours of free time. So the slope of the feasible frontier is the MRT. The tangent line at A is the marginal rate of substitution at 10 hours of work or 14 hours of free time. And so what we can see is that at this amount of time, so at 10 hours of work, MRT is less than MRS. The slope of the reservation and difference curve exceeds the slope of the feasible frontier. And what that means is that we could actually work less and be able to increase the surplus that can be shared between them. So the distance between these two functions represents the economic surplus that can be shared between them. When MRT equals MRS, the economic surplus that can be shared is maximized. So the reason why the vertical distance between these two functions represents the economic surplus that can be maximized is because Dipuyo is going to try and get Karabo to accept a contract that puts her on her reservation indifference curve. In other words, he's going to try and get her to take a contract that makes her indifferent between working and not working, because then he gets to keep everything that remains. So if she worked 10 hours, he would try and get the allocation to be A, which means he would get to keep the difference between E and A. But we can see that that distance could be bigger if she works less. So we would find that the vertical distance between these two curves would be maximized when the slopes are identical. And that's going to be the point where we get Pareto efficiency. Okay, let's just quickly do C and D, and then I'll come back to Pareto efficiency. So C says, explain what happens to the graph as a result of a drought. So there's a persistent drought that leads to chronic water scarcity, and there's a permanent reduction in grain production. So what would happen to the graph as a result of the drought? The result is going to be exactly the opposite of what we saw earlier when we looked at an increased production. When there was an increased productivity, we saw that the feasible frontier would expand, and that would increase the economically feasible set. The opposite is going to be true with the drought. If there is a drought that permanently reduces the amount of grain that can be produced, the feasible frontier would shift inwards. So what we would say then is that the feasible frontier would shift inwards and the economically feasible set shrinks or becomes smaller. So the result of the drought is a smaller economically feasible set of options. And then D asks, which of Karabo and Dipuyo would prefer allocation D over allocation A? Justify your answer. So here we're looking at allocation A and allocation D. Okay, so let's just ask one at a time. Do you think Karabo would prefer D or A? So would Karabo prefer D or A as an outcome? D, yes. So Karabo would prefer D because D lies above the reservation indifference curve. A is on the reservation indifference curve. So D gives her more utility than does A. Okay, so she would prefer D over A. So we know that Karabo would prefer D. Okay, but what about Dipuyo? So Karabo prefers D. Now let's look at the situation from Dipuyo's perspective. So if we're at A, Dipuyo gets this amount. If we're at D, Dipuyo gets this amount. So would Dipuyo prefer A or D? Dipuyo prefers A because the amount that goes to him is greater than at D. So Karabo prefers D, Dipuyo prefers A. Okay. And the reason, so it says justify your answer. So D gives Karabo more utility than A because it is above the RIC, and D gives Dipuyo a smaller surplus than A. Okay, so there's the justification for that answer. So now I want to go back to question 10 and 14. I'm going to use this picture over here to explain it. So how do we find the Pareto efficiency curve? So what we just established just now was that we're going to find maximum economic surplus when MRT equals MRS. In other words, when the slopes of the feasible frontier and the reservation and difference curve are the same, we have maximum surplus. Yeah, so that's roughly around here. So at this point here and at this point there, the slopes are identical. And we would call this line the Pareto efficiency curve. And the Pareto efficiency curve is determined by all allocations where MRT equals MRS. It's Pareto efficient because if we move anywhere off of this line, someone is going to lose. Because the vertical distance between these two curves, either side of our line, is smaller than the vertical distance at the Pareto efficiency curve. And so if the surplus that can be shared between these two people is smaller, either side of this Pareto efficiency curve, that must mean someone's losing. Right. So surplus gets smaller when we move away from the Pareto efficiency curve. So question 10 said, in a voluntary exchange between two parties, the Pareto efficiency curve shows allocations that make participants better off than they would be without an exchange. So here we have Z, which is the outcome with no exchange. If we compare Z to the point at the bottom of the Pareto efficiency curve, we've already decided that this is a Pareto improvement because this point compared to Z makes Angela no worse off, but it makes Bruno better off because at Z he gets nothing, but here he gets this whole surplus to himself. So this is a Pareto improvement over Z. If we had to move just a little bit above that point, Bruno would still be better off because he's getting much of the surplus, and Angela is better off than Z because she's getting a little bit more utility than what she gets at subsistence. Sorry, at reservation. As long as we keep moving up this line, any of these allocations make at least one or both of these people better off. And so every point on the Pareto efficiency curve is a Pareto improvement over Z. And so the answer to 10 is true. All allocations on the Pareto efficiency curve make participants better off than they would be without an exchange. Okay, so this statement is true. For 14, the question says, in a problem involving exchange between two parties, the Pareto efficiency curve shows. So A says, all exchanges that make both parties better off than they would be without an exchange. Now, the key word in this statement is all. And the reason why I say that is because think about point E again. Point E makes both of them better off than at Z. But is point E on the Pareto efficiency curve? No, it isn't. So are only points on the Pareto efficiency curve Pareto improvements? No. All points inside the economically feasible set are improvements over Z, but only the points on the Pareto efficiency curve are Pareto efficient. So all of these points here are Pareto improvements over Z, but they are not Pareto efficient. They are Pareto inefficient. So A is incorrect. B says the one exchange. So the Pareto efficiency curve shows the one exchange. That is incorrect because the Pareto efficiency curve shows a range of options. It doesn't just indicate one option. These are all potential options. So B is incorrect because it says one. C says all possible allocations of goods between both parties. That is incorrect. What we see is all of the allocations in the economically feasible set are potential allocations between these two groups of people. D says all possible efficient allocations. That is correct. Okay, so making a deal is an improvement over no deal, but only some of those deals will be efficient. There's a question in the chat that says, does that mean the higher on the Pareto efficiency curve, the better off they are? Not exactly. What it means is that the higher up the curve, the better off one person is. So when we're at this point here, at the bottom of the Pareto efficiency curve, Bruno is better off than at Z, but Angela is no better or worse off. If we move up the line, Angela becomes better off, but Bruno becomes worse off. He's better off than at Z, but he's worse off than down here. So when we're moving up along this line, what we're saying is that Angela is getting more bargaining power. If we end up at the top of the Pareto efficiency curve, it means Angela has all the power in this bargaining relationship. If we're right at the bottom, Bruno has the power. Where we end up along this line will depend on the power of, or the bargaining power of these two people. So if Angela has a lot of bargaining power, we'll end up somewhere near the top. If Bruno has a lot of bargaining power, we'll end up somewhere towards the bottom. And if they have equal bargaining power, we'll end up somewhere in the middle of this line. Okay, could you go over why A is wrong again, please? Okay, so the reason why A is wrong is because it says the Pareto efficiency curve shows all exchanges that make both parties better off than they would be without an exchange. What this is saying is that only points on the Pareto efficiency curve are improvements over no exchange. And what we did earlier is we showed that a point like E, which lies inside the economically feasible set, makes both people better off than no exchange at Z. But E is not on the Pareto efficiency curve. So the definition of the Pareto efficiency curve can't be that it defines all exchanges that make both parties off. What it defines is exchanges that make both parties better off and are efficient.